And welcome to the daily space weather. Take 4. Let's don't get to... Actually, this is take 5. By the way, don't ever listen to this song, released in the 1974 Christmas special, The Year Without a Christmas. I've borrowed Heat Miser's hat for the creation of this video. It's to cheer me up as I'm on take number 5. Alright, so here's the sun on 171 angstroms. We do see a giant filament here, which collapsed back onto the sun, actually, onto the chromosphere. And we see a sunspot up here at this high latitude underneath my pointer. And that is already evaporated, but we do see umbra. So here's the 171 angstroms view. This is 9.5 hours worth approximately. There are the date stamps. And this is the same date stamps. And you see that umbra has already shrunk into a non-sunspot. But it's at a high enough latitude that we would assume it's a cycle 25 sunspot. Probably not going to be named. I'm not exactly sure on how long it has to have an umbra to be named, but here's the X-ray imager. And the X-ray imager showing that. Let me let that play. And let this play. As we don't play on this channel, even if the live streaming doesn't function. And there you can see a little bit of X-rays coming out of that hot region, hot magnetic region that is. And here's a close-up. There you can see the magnetic fields. And the main field looks like it's actually South Pole. But there really is only one umbral field there. So it's a little deceptive looking. And going back to solar data, electron flux is quite flat. Relativistic electrons similarly in a moderated range here. And we see a couple little spikes in the GOES magnetometers, nothing to write home about. Here's the Gong 2 data. It's showing up 1 hour and 26 minutes old. And Earth's field line is solidly in the South Pole oriented portion of the current sheet, shown here in red. We're going to show you some great images from the Parker Solar Probe, folks, so get ready for that. Get ready, strap yourself in. It's not till the end of the video. But so we see the phi angle has shifted all around over the past 24 hours. And solar wind density, 6.1 protons per cubic centimeter. Solar wind speed, 375. So a slight ramp up in solar wind speed and density here has brought the KP up to 2, I believe. There's the data from ACE. First, we're going to look at magnetosphere movies. And there you see the pressure very weak. And by the way, we do see in the ionosphere, down in this region, we do see charge ups happening. It's like a seasonal sort of a seasonal sort of thing during a weak solar wind, if that makes sense. And there we see a small increase right at the end of the video there. Here are the global magnetic perturbations, and we'll see a little bit of induced current here. Since that thing refreshed, let's let it play through 4 hours of data. The main perturbations we see are over the Canadian North Pole, not the Siberian one. And we see the South Pole continuing to creep into the southern Indian Ocean there. Not a huge amount of current. We do see ionospheric anomalies. And here they are. I'll actually reload that. There we go. And there's 6 hours of the ionosphere. And it's looking quite wobbly here. Southern hemisphere being a little charged up. South Pacific, south-southeast of Hawaii. We see a large charge disparity there, where it's staying charged at night, being heavily discharged nearby. So you see the, anyway, let's bring up the latest image here. You see this, it's all the way up to 9 megahertz southwest of Hawaii, and only 2 megahertz. So barely even an F2 layer there, and only an F layer here where this red blob is. And we've seen that going on for about 2 weeks. And the KP is actually back down to 1. And that's the kind of thing that happens when we're on take 4, as the data is time sensitive. So anyway, KP down to 1, and we're skipping cosmic rays, although we always leave links to this site so you can monitor them yourself. Don't take our word for it. Largest quake of the past 24 was 5-point-something magnitude in the Philippines. And a few deep quakes like this, 4.6 in Indonesia. That's 4.6 magnitude, 306 kilometers depth. There's the largest quake of the past 24, was a 5.5 at the Philippines. And it looks like one came in between take 4 and take 5, or whatever take we're on now. Take X 4.33274, J plus X exponent 3. Please leave a comment if you enjoy the naming conventions of stars, galaxies, supernovas, etc. Here's a deep quake of Fiji. Extreme depth, 536 kilometers, 4.3 magnitude quake. A deep one in southern Mexico there, 142 kilometers. And occurring only a half hour later, 4.9 at Indonesia, at nearly the same depth and the same magnitude. How about that? Deep quake in Alaska, that's only a 3 magnitude. Here's a deep quake in Peru, Western South America there, 148 kilometers depth at a 4.4 magnitude. And moving on to the pressure maps at windy.com. Bring this back. There's the current pressure. And it's about 4:45. That's AM. And we'll just let this advance. I believe this is a GFS forecast, and that is paused for some reason. Let's just move on to the volcano rundown. Looks like a volcanic downtick, folks. We see activity at Mount Aso, flight level 6,000. Explosive activity at Doppler, flight level 7,000. Fuego and Revenador are not showing any volcanic ash emissions in the satellite. Sabancaya continuous emissions, and Nevados de Chilean exploding, producing a 14,000-foot ash plume. Please do not pole vault Nevados de Chilean unless your personal pole vault record is 14,000 feet. Actually, that would be from sea level, but let's don't get into it. Let's look at where objects are in the solar system, shall we? There's where things are now. There's where things will be in 1 week. Milky Way galaxy team for the win as we overcome the most annoying software you could possibly imagine and escape unscathed as we wade through a quagmire of junkware. In-the-sky showing Cygnus just about to rise. Are you familiar with Cygnus? Now this star is allegedly the other North Pole star, right? The other North Celestial Pole, the other end of the precessional cycle. It's also the most intrinsically bright object in the entire galaxy as far as we know. And we won't get into it, but Deneb is just about to rise. How do you like them apples? By the way, welcome to the Neo-Renaissance. Check out smAsho.org. Lots of changes coming there soon. And thanks to all the viewers for helping to support the channel. We're also on BitChute, by the way, and making sure all our videos are archived there. I think there are already hundreds of them, so perhaps check us out there, bitchute.com/smAsho, as well as on Instagram. Here's yesterday's side view sunrise. A great example of when different altitude clouds play with the light, blocking some of the sunlight from above, creating grayish clouds. Please leave a comment if you've seen purple sunrises and sunsets and associate those with volcanic activity, as you're going to see a lot of those. And check out lightningmaps.org. We got some lightning coming down in the US. Check out this errant bolt right here. Just a bolt came down by itself. It's probably going to be a loud one. And it's not zooming in. I don't know where it's located. Anyway, check out lightningmaps.org next time you hear thunder. And zoom in on your location, because you'll actually be able to see the sound waves, theoretically. There you go. And I don't know what town I'm looking at here. I gotta put it back on, I don't know, terrain. That's cool. Looks like an unpopulated area there, folks. Anyway, here's the US Doppler radar. Looks like the snow is subsiding a little bit, some lake effects there, and some minor thunderstorms over Missouri and Arkansas. Here's a zoom into that convergence zone. And here's the full view in water vapor. When you're looking at the Doppler, folks, and you don't know what it means, check out the water vapor map. It will tell you what even the invisible water vapor is doing, as Doppler is only measuring vertical motion in the cloud layer, where the water vapor map, nothing hides from the water vapor map. It sees even water vapor that is not condensed onto clouds. Actually, quite an interesting convergence zone there over Kansas. Let's take a look at that in the water vapor map. Right over the Oklahoma panhandle here. We've got two different zones of moisture, both kind of pointed into that same spot of dry air. See, zoom out a little bit. There we go. It's actually a two-way convergence there. And you can see a whole bunch of low clouds are probably there. We won't get into it, as there's still a lot of stuff to cover, such as the Parker Solar Probe. We did a small little data grab as we try to go through it piece by piece. And we're looking at nullschool.net. There's the jet streams of the Western world. Pretty serious low pressure system there, rotating counterclockwise off the coast of Washington and Oregon. And here's the jet streams of the east. By the way, there's some extreme meridional jet stream flow there over Asia, as well as really bizarre patterns in spring in the southern hemisphere. There's the view from Antarctica. We have massive bends in the jet stream down there. By the way, consider supporting us on Patreon, the main source of funding for the channel. Patreon.com/smAsho. We've got two layers, the gold layer and the intro layer. And thanks, Smash Team. And get ready for lots of other stuff. By the way, thanks everybody for your hard work sharing the videos. And to all of our value chain partners. We've left links to two or three different sites here about solar radio data as we talk about the 10.7 centimeter radio flux daily. That is an analog to Sunspot number. We do also, on this channel, follow the 245 megahertz radio flux. as that is seen as one of the predictors to solar activity, and we're not going to get super in-depth into what that means so we can get the video out, but talk about the layers of the sun. So the photosphere, that's what you're seeing when you see a sunspot. You see that dark umbra. You're looking at the photosphere, that dark area, believed to be 6,000 degrees Celsius. And then you've got the chromosphere, which is quite thick, and that's kind of the outer solar disk that you're typically looking at. Unless you're looking into a coronal hole, then you're looking through most of the chromosphere. And then you've got the corona, that's the very hot outer region. And the Parker Solar Probe has returned some of the most detailed images of the corona ever seen. So we're going to show you that in a moment, but first, suggest that you check out zooniverse.org. They've got a Galaxy Zoo project, and here's what happens. We have a nearly edge-on disk here. This is a good one. We need humans to classify galaxies. We're going to call it an edge-on disk because it's pretty close. As we may be able to see some jets coming out of this thing or something, that's kind of why these are interesting, as perspective is everything in cosmology. What do you say? Boxy, bulge, no bulge? I'm going to say no bulge. Please leave a comment if that's what she said. It does not appear to be merging or disturbed. By the way, set yourself up a login for this, as we've seen citizen scientists already published in scientific papers, simply by classifying galaxies this way. I'm going to say I see some overlap, but that's about it. It could be behind the galaxy. And there you have it. So check out Galaxy Zoo if you want to go classify galaxies. Now, I like fast things, peregrine falcon being one of my favorite animals. Here's a fast thing. Let's talk about this one, the Parker Solar Probe. As far as we know, because we don't know all of human history, obviously, but as far as we know, the fastest object ever built by mankind is the Parker Solar Probe. It's completed a few of its orbits, and it's dumped some data. One of the most interesting things is something that those of us who have been studying electric universe and things like the Sapphire Project are not going to be too surprised that the ESIS instrument has returned some data already showing unexpected heavy elements out in the corona. And since the Sapphire Project produced heavy elements in its experiments in the gas, in other words, not just on the anode or the cathode, but actually in the atmosphere inside the Sapphire chamber, it's not too surprising to hear about sudden bursts of energy accompanied by the arrival or detection of unexpectedly heavy elements in the sun's corona. So that's kind of important, and we're going to get into that in depth at a later time. Now, if you want to look at the data that the Parker Solar Probe has been returning, we've got links to all that below the video. There are a whole bunch of links, so you have to make it through these yourself. I believe the APL Parker Solar Probe Gateway is the one you really want. Now here are two images, and you're looking at the Parker Solar Probe's orbits here, obviously. And these are not synchronized, I don't think. In any case, when you see this is turned on green, that means it's returning data. And again, we link to all of this. And while it's not the most important stuff, here's some data from the Whisper. And this is the only imager on the craft. There is an outer and an inner camera. We're using the inner camera right now. And you'll see some fairly anomalous looking things in this, as we now know that the magnetism is reversing as the plasma exits the corona, or exits the chromosphere, I'll say. it doesn't just come out in a steady stream, it actually reverses and then suddenly heads back out again. So it seems like solar magnetic pulses would cause this sort of behavior. But without getting too in-depth into it, at this point, here is some data. This is 1 week from, I believe it's from 4/3 to 4/10 of this year. So fiddle around with that. We've left links to this as well. Some of the most detailed images of the corona we've ever seen. Very high resolution and very close up. So while it looks similar to what we see from stereo A, it's quite a bit closer to the sun. We'll just let that play all the way through again, as we'll be featuring small snippets of data from the Parker Solar Probe on a daily for the next week or so at least, if not the next year. And believe me, there's plenty of data to look at. This explains a lot about, for instance, why when we see coronal mass ejections, they come out in this bubble sort of a pattern. And perhaps this is some sort of a ability to predict that pattern. But most importantly, it's a whole lot of data, and there's going to be a whole lot of crunching of said data. Everybody's going to have washboard abs from doing that much crunching. And we left links to that as well as the SciTech Daily article about Parker Solar Probe. It's a very long, in-depth article, and SciTech Daily is a highly endorsed publication. Get those wheels about how the sun works turning in people's brains, and remind you that this is what the sun looks like from above the North Pole, with that enduring coronal hole. So there's a lot more than meets the eye, folks, and thanks SMASH team for tuning in. Let's head back for one bonus feature. Or we're going to do it as if the stream was live, even though it ain't. Going to bring up the 304 angstroms view as we have one massive filament collapse has occurred. And we'll just let that load. Man, I apologize for the delay. SDO is taking a while. Anyway, there's a still image. It is one heck of a giant filament. Perhaps that'll be the thumbnail. Thanks again for tuning in, everybody. Thanks for tuning into the premiere, those who viewed the premiere on YouTube, as we try to keep the channel as interactive as possible. Look for another video coming out this afternoon, most likely. And remember, when you're staring at the sun, don't drink it. If you drink, stare at the sun anyway. Just don't drive. Use the proper instruments like the SDO or perhaps a solar filter. And since it'll never be now again, welcome to the neo-renaissance. May that solar wind be at your back and that atherosclerosis absent from your veins.